Hello, I'm Mr. Hill, and today we're going to be going over laws of exponents. Okay, so first we need to know what an exponent is. Just in case you haven't remembered what an exponent is, we're going to do a little short review. So what is an exponent? According to this definition, it says that an exponent says to multiply the base a certain number of times. Now, certain number of times, what? Okay, the number of times to multiply that base is the number of the exponent. Okay, and another word for exponent that you will probably hear is the word power. So, looking here, we have 2 to the 4th power. Now, there isn't a special name for 2 to the 4th, so we're just going to say 2 to the 4th power. So if I'm going to write this, here is the exponent, and here is the base. So 2 is the base, 4 is the exponent. Now let's actually do what the definition tells us. It says to multiply the base a certain number of times, and that certain number of times is the number of the exponent. So this tells me to multiply 2 4 times. So if I'm going to expand this out, 2 times 2, 4 times. And that is what an exponent is. Next, we're going to be going over the product of powers. So the product of powers helps us to multiply things with same bases and figure out what that exponent does. Now there is a certain formula to it, and that formula is a to the m power times a to the nth power, and it's going to be equal to a to the m plus n power. Now just looking at these is kind of confusing because it's all just numbers and there's no numbers to it. And there's all just letters. My apologies, it's all just letters and there's no numbers to it. So let's just try to read this definition and see if we can make some sense out of it. So to multiply same bases with exponents, keep the base and add the exponents, or powers. Obviously, that is exactly what we see here. We have a base with 2 exponents. When we equal it, we're going to say keep the base, which is a, and add our exponents. That's exactly what our formula says. So let's do this quick example of 3 squared times 3 to the 5th. So we have 3 squared times 3 to the 5th. If I simply follow my formula, all I'm doing is rewriting my base and I add my exponents. And then we calculate that out because we can calculate 2 plus 5. 2 plus 5 gives us 7. So there you have it. We just used the formula to figure out what 3 squared times 3 to the 5th power is. But as the question says, what is actually happening? Sure, you can just use the formula, but when I don't know what's going on, I just can't take a formula for granted. I just can't take it as known facts. So let's kind of go over what it actually means. My motto of the day, if in doubt, expand it out. So when we do this, that just means if I see something with an exponent, I'm just going to expand that out to see what's going on. So if I take that previous example, we know this equals 3 to the 7th power. Now let's find out why. Well, I know that 3 squared is the same as saying 3 times 3. That's what x squared is. 3 to the 5th power is 3 multiplied by itself 5 separate times. So this means that I can simply replace the expanded form from the actual equation or the actual problem that we have. So we have 3 squared times 3 to the 5th power. Let's expand it out. 3 times 3. Well, this is just simply that 3 squared that we had. I still have the multiplication. 3 times 3 times 3. 5 separate times. And this is just simply 3 to the 5th power. Now we have to remember what an exponent actually is. An exponent tells us to multiply the base by a certain number of times. And that number of times is going to be the number of the exponent. So how many times are we multiplying 3 here? Let's count them up. 1, 2, 3, 4, 5, 6, 7. So we still get the same answer if we follow the formula. So this is what I mean. If you can't remember the formula, when in doubt, expand it out. We're going to do another couple of problems, but in this case, it's going to involve variables. And so in this example, I have 2 of the same variable, which is x, and they each have an exponent. Yes, it's the same exponent, and so what we're going to do is we're going to multiply them out, which means we add our exponents. So let's just do that with the base. Let's just do that formula. So we get x to the 3 plus 3, and we can calculate 3 plus 3, and we know that that is 6. So we're going to get x to the 6th power. But, when in doubt, expand it out. So if I don't remember that formula, I'm going to expand it out. So I know that x cubed is just simply x times x times x. And I don't have to write that again because they're both x cubed, and I'm not going to do that. So what we are going to do, though, is expand our problem out. So we have x times x times x. This was our first x cubed. We're still multiplying. And then here's our second x cubed. Now remember that an exponent is just multiplying the base by a certain number of times. The number of times is the number of the exponent. 1, 2, 3, 4, 5, 6. Multiplying that same base 6 times, and that's going to be my exponent. X to the 6th power. So we still get the same thing if I do x to the 6th. I'm going to get x to the 6th if I both use the formula and the expanded out form. So here are some test questions that you might be seeing involving the product of powers. So I'm going to read the question out loud just in case you can't read it on the screen. So a rectangular prism has a width of x inches and a length of x squared y inches, so x squared times y inches, and a height of y squared inches. Which expression represents the volume in cubic inches of the rectangular prism? So first we need to know some of the key components of this question. So the key thing is we're trying to find volume. Now volume of a rectangular prism is length times width times the height. We know all 3 of those components. We know that the width is x. We know that the length is x squared y. We know that the height is y squared. And of course, all of these are in inches. I'm kind of just not writing those down just because it's tedious and I don't need to in order to figure out what the final answer is. Now with volume, we're multiplying all of those together. So let's see what that's going to look like. So V is going to look like x squared y times x times y squared. I put it in parentheses because we can also represent multiplication by every single term in parentheses. Now, we know that since this is product of powers, we have bases that are the same with exponents. We know that we keep the base and we're adding the exponents. So we're going to end up getting v equals x2 plus 1, because I have an x squared here and an x. If you see a variable just by itself, it has an invisible 1 in the exponent like you would see a coefficient. And then we have times y to the 2 plus 1. Let's write that in the order we see it. I'm sorry. So 1 plus 2. That way we can just keep everything consistent. Now we know how to calculate 2 and 1. We know how to calculate 2 plus 1. And we get 3. So our answer is x cubed, y cubed. So your answer choice will be D. Dang.